Hi, ladies and gentlemen. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Concord, New York, and there's my email address. We are doing Unit 6. Before we hit page 29, and we're going to be talking about the shifting of parabolas. Now, he said that we're completing the square. We're not completing the square. We're going to be stopping a couple of steps before we're done completing the square. What he really means is we're going to be getting into vertex form. So let's take a look at a PowerPoint presentation. So what I want you to do is when you get out a piece of paper, we're going to be writing down vertex form of a quadratic equation, algebra versus geometry. And our notes, here's an algebraic example of how the vertex form of a quadratic equation works. Then we'll show you why it works using geometry. So here we're starting off with an equation. You notice that here it's not in standard form, but that we have it equals 10 instead of equaling 0. Okay, so we want to have this on one side, the constant on the other side of the equal sign. We're going to cut the coefficient of the x, that's the 6. We're going to cut it in half, square it, and add it to both sides of the equation. What? Half of 6 is 3. We're going to square it, 3 squared, add it to both sides of the equation so that it's still equal to each other. If we add 3 squared to the left side, we have to add 3 squared to the right side to make it the same. If we divide everything by 2, that means divide the left by 2 and the right by 2. Okay, so that's what we did. We just cut it in half and squared it, added it to both sides of the equation. What does it look like? It looks like x squared plus 6x plus 9 equals 19. Now, it can be expressed as a square of a binomial. When we factor this, the x squared plus 6x plus 9, it factors into x plus 3 squared. That's why we call it a square. This is going to end up doing completing the square, but we're getting a vertex form first. So this is what we have. The 19 is still on the right-hand side. We factored the x squared plus 6x plus 9, left the 19 alone. Now we're getting into vertex form. So we have to rearrange the equation so one side is 0 and the square is positive. So we're not going to move this. We're going to subtract the 19. Now we have x plus 3 quantity squared minus 19 equals 0. This is vertex form. It tells us a lot about what's happening to the parabola. Let's take a look at this with geometry. We have a square. Okay, that's the x squared plus 6x. It's the yellow box. The blue box is the 6x, so we're adding 6 and x. This is 6 long, this is x high, so that's x high. So this area is 6x, that area is x squared. So according to the technique, we cut the 6 in half, then square it. So let's cut this in half. We're going to separate the rectangle, rotate it, slide it underneath. So this is called completing the square. Now, how big is this piece here, right here? It's 3 high, and 3 wide, 3 wide. So it's half of b, half of the 6, and squared. 3 times 3 is 9. So we've got to add this. That square is 9 in size. Make sure you have this drawing. In summary, we started with a rectangle, not a square, and that's what it was. That whole thing is going to equal 10 hectares or 10 acres or something like that, because this all started with dividing land. There's the rectangle. We changed it to a square by rearranging the rectangles and adding 9. That's half of b squared. Then set it equal to 0. That's what it looks like geometrically. This allows us to see the movement, key, make sure you got this down, of the mother function, the original parabola, y equals x squared. The function moves left 3, Left 3, yes, that says plus. We're going to move to the negative 3 and down 19. Yes, that says negative, so we move down 19. That's what happens to the original mother function. If you have any questions, make sure you ask me in class. Catch you later.